I'm going to be sharing with you some research done by many of my colleagues here at the USGS. We work at the Southwest Biological Science Center in Flagstaff. I'm going to be going over status trends and some of our explorations around drought and aridification. As Tani mentioned, I coordinate the RAMPS program, which is the Restoration Assessment and Monitoring Program for the Southwest. Here we're connecting science and land management to enhance Southwest ecosystems. You can see the geography of where we work. We're understanding how land use change and climate change impacts this geography and work to explore paths to mitigate some of the impacts and expand conversations about what actions are possible given sort of an unknown future. So the outline of my talk is I'm going to be talking about patterns of drought and aridification and some implications and actions. So first, just to kind of talk about what we mean by these words, drought, is it drought? Is it aridification? Is it a mega drought? I want to tip my hat to this amazing episode, recent episode of the Come Rain or Shine podcast that's put out by the Southwest Climate Hub. They recently interviewed Connie Woodhouse and Mike Crimmins around what we mean with when we use these words. But in general, the differences between them are around the intensity of the drought, the duration, so the time, and then the geographical extent. And I also want to just lay some groundwork here by talking about this really amazing study that came out where they did tree ring reconstructions of the Colorado River stream flow. And in the paper, they suggested that the 22-year period between 2000 and 2021 could be the worst drought the southwestern US has experienced in 1,200 years. So I'll just pause there for us to think about what this might mean to the actions that we take on the land. And next, I'm going to talk about some modeled changes, so what we might expect in the near and long term, and maybe some paths for exploring what to do about it. So first, I want to highlight some work done by John Bradford. And I'm going to go step you through this graph that was produced for Wapatki National Monument, and this is around Flagstaff. But he's made these graphs from many locations throughout the Southwest, and they all follow the same general trends. So the red lines are temperature, and the blue lines are precipitation. And the dark, narrow line is sort of current, what's happening now, and the wider lines with the lighter colors are what's projected to happen in the near and long term. So you can see that it's projected to get hotter over time, and precipitation is a little bit less unknown. But what's really cool about this work is that John went one step further and asked, what does this mean actually for vegetation dynamics? And of course, what really, when drought really hits us, it's really about, for ecosystem processes, the amount of moisture in the soil. So this graph here is showing the black line is sort of currently when moisture is in the soil. The top dashed line is showing soil water potential at 1.5, which is sort of a broadly accepted wilting point for many plants. And then the lower dashed line at 3 is showing where you're going to have dryland plants experiencing more moisture stress. And so anyone that lives and works in the Southwest knows that that period, sort of right before the monsoon, maybe late May, June to early July, is a critical time for drought stress. And what this science is showing is that this period is projected to be much longer, and we're going to get earlier spring drying. So let's zoom out. So this is for Wapatki, or one point on a map, but let's zoom out for the entire Western US. And so this map is showing on the left dryness in the top layers of soil, and on the right dryness in the lower layers of soil. And the light blue is sort of status quo. Greener colors are maybe wetter conditions projected for the future, and brown colors are drier conditions. The crosshatch is showing 90% confidence intervals for where the models agree. So pretty robust predictions here. The topsoils, which really matter to some of our herbaceous plants, look to be dry throughout most of the Southwest. There might be some areas where it's about the same as it was in the past. And then for those deep areas, which really going to drive vegetation dynamics, we're looking at a lot drier areas. So then we want to look at, are we seeing shifts already happening on the landscape from this aridification and drought? And the answer is yes. So Seth Munson took some long-term data that was collected by the National Park Service and asked at many different locations, are there changes in cool season grasses? This is the chart on the left. And then shrubs, which is the chart on the right. And so we're seeing declines in cool season grasses and maybe slight increases in shrubs. And then we looked, can we get really detailed patterns of niche modeling for various species going into the future? And so this was research led by Carrie Havrillo when she was a postdoc with us at USGS. She's now at CSU. And so she worked with many managers to identify priority grass species, in this case, cool season grasses, and is looking at shifts in their distribution. So the brown colors are going to be a shrinking of the distribution, and the cool colors, the blues and purples, are going to be increases. So we see that cool season grasses for these species look to decline in the most part, except for maybe rice grass, which was a cool outcome. She did the same thing for warm season grasses, and we can see where most warm season grasses may stay the same or increase, except for maybe blue grama, which is really interesting considering a lot of the rangelands, at least on the Colorado Plateau, have pretty low diversity and are covered with blue grama. So this is something that range managers here are really paying attention to. And we saw this happen a couple years ago in response to a couple years of drought and no monsoon, where we had blue grama die off on a lot of these ranges. It's since kind of bounced back, but we're kind of seeing how these results are showing up in real time for us. So with a little bit of time that I have remaining, I just want to go through some explorations of what we're doing about all of this, because I don't want to present all of these big impacts without also presenting a little bit of hope for the future. And I'm not going to promise that anyone has solutions, but there are avenues that we can explore. So some of the impacts include challenges to revegetation. We all know that if it doesn't rain, our seeding efforts don't produce the outcomes that we want. So we're working with this project called RestoreNet, where we have some 24 locations across the Southwest, and we're testing various treatments that when it does rain, it'll keep the moisture in the soil a little bit longer. And we have a couple papers out with some cool guidance on this. Another thing we're looking at is dust, because as vegetation shifts, you get lots of bare ground. And this really matters for lots of people, including folks on the Navajo Nation. So Seth Munson, Travis Nauman are working with a PhD student, Markel Begay, to develop these dust risk maps across the nation. And land use planners are using these maps to help people site their homes in places with reduced dust risk. And then Markel is taking these maps at the chapter level out to chapter houses and asking community members what this might mean for them and how dust is affecting them, specifically in regards to producing food. Another thing that we're doing is working with land managers to develop nuanced, detailed reports of exposure and sensitivity. Some of those niche models that I showed that Carrie led are in this report. And then we produced this menu of options for people. And this menu kind of expanded our minds about what's possible given some of these impacts, given us more nuanced approaches to some of these impacts. And then also we added sort of social political structures into this so that we can think more long-term about maybe some work crews or different ways we can promote more proactive management in regards to some of these new changes. So I'll just leave it at there and conclude that drought and aridification is happening. It's predicted to continue and intensify. This shifts vegetation dynamics and interacts with land use to have huge impacts, which is shifting business as usual management. But restoration, science collaboration, and conversations are helping us explore paths into this unknown. And here's my contact information. So I'll end with that. Thank you.